Welcome, everybody, to our third in our winter webinar series here. We got a jam-packed webinar today. We have three awesome presentations from Cheryl Post, Paige, and Emilia Stepinski, and they're going to be talking about their projects on invasive new tools in the toolbox, alternative tools for managing and monitoring invasive species. So I'm happy to introduce our first speaker, Cheryl Post. Cheryl is the Natural Environmental Specialist with the City of Toronto in the Urban Forestry Department. And over the past decade, she has specialized in natural environmental infrastructure projects that protect and enhance Toronto's urban ecology, such as wetlands, boardwalks, and sustainable trails. She recently spearheaded Toronto's innovative Prescribed Grazing Project, the first to pilot this type of grazing for urban ecosystem management in Ontario. So over 60 goats were recruited for this groundbreaking project, and I'm really excited to learn more about this project, and I'm sure a lot of people are. So with that, I'll stop sharing my screen, and Cheryl, I'll pass the mic over to you.
Hi, everybody. Welcome and thank you to CCIS for having me. I'm Cheryl Post. I'm a natural environment specialist with City of Toronto Urban Forestry and the lead project manager for Toronto's Prescribed Grazing Project, which I'm really looking forward to speaking about here today. So before I go into Toronto's pilot project specifically, I really wanted to step back and discuss what prescribed grazing is and why it can be a useful tool. So prescribed grazing is the process of using a variety of different types of livestock, like sheep or goats, um, to achieve specific land management goals in ecosystems that are well adapted to grazing, particularly meadows or prairies. The overarching concept is really to mimic the evolutionary adaptation of large grazing herds in these ecosystems. So historically, large grazing herds have shaped prairies and meadows as they evolved together. So think mastodons, mammoths, deer, and even camels, evolving over 30 million years and exerting pressure on the landscape and soil ecology over that time. So now in modern times, land managers are sort of attempting to mimic the actions of those ancient herds with domestic livestock to preserve ecosystem health and diversity. So now it's important to note here that while I focus mainly on grazing in meadows, since that's the focus of my pilot, it can also be used in other types of land management with varying goals. So think, for example, grazing in road right-of-ways or on solar farms or in forest understories. My focus here is on meadows, but that grazing can be used in lots of different ecosystems for different goals. So prescribed grazing has been shown to have a number of potential management benefits, like helping to control invasive, non-native, or incompatible plant species. We do like to differentiate those terms here since there are subtle differences between those designations. So poison ivy, for example, is a native plant, but in urban ecosystem management, it can be locally incompatible with land use. And if it's sort of encroaching on areas that come into contact with park users. Grazing can help reduce or eliminate woody invasive, eliminate woody vegetation encroachment, be it invasive or non-invasive, which I'll go into a bit more in a minute. It can also improve native species regeneration and diversity over time, improve soil characteristics and nutrients, and in some cases, it has also been used to reduce fire hazards. So I did want to narrow it in a bit as to why this can be beneficial as a management tool specifically within the urban context. Historically, grazing has been used outside of the urban context fairly often, but it's relatively new within the urban context. So we all know that in urban ecosystems under pressure, maintaining habitat and species diversity is important, and that the more habitat diversity you have, the better your species diversity is likely to be. So in Toronto, for example, some areas of our natural parkland are purposely maintained as meadow habitat as opposed to forest habitat or wetland habitat. Um, Meadow habitat is often somewhat rare or underrepresented in urban areas. But we can only do that through ongoing and somewhat intensive management efforts, or that diversity could be lost. So native meadow habitats are often rare since they're considered kind of a subsuccessional habitat type, which means If they're left alone, they would eventually become forests over time within this area as trees and shrubs begin to move into the area and take root. Overall, meadow and prairie habitat types are also at risk of invasive species encroachment in addition to woody encroachment. So if we want to retain healthy, diverse meadow habitats, we really need ongoing management with integrative techniques, things like burning, chemical, mechanical, manual methods. Um, this again is why a management tool like grazing that can directly help reduce woody and invasive encroachment can be such a good fit here in urban ecosystems. So it's also important to note that integrative management is really the name of the game in managing complex urban ecosystems. So since it's pretty rare that only one management technique or tool can really do the job all on its own, there are so many techniques and tools that are part of that puzzle. Um, Things like mowing, mechanical, chemical, even prescribed burning, all of which we use in Toronto, with each having its own effective niche. So the benefit of grazing is that it can be really well integrated with those best management practices. It doesn't have to be either or. So the Prescribed Grazing Pilot Project really looked to introduce grazing as a new environmentally friendly tool to our meadow management toolbox, so to speak. And as we look to incorporate grazing into our management practices, we're also particularly interested in the unique benefits that it can offer versus, say, only mowing or only chemical control, some of which are pretty compelling, like reduced carbon emissions, reduced impacts to ground nesting, burrowing, or slow-moving animal species, the possible reduction in chemical herbicide requirements over time, and the potential for soil improvements, which very, very few other management opportunities provide. And as well, there's the really important value added potential of public engagement and education, which I'll bring up a few more times in the presentation, and the opportunity to promote the efforts of land managers. There's not a lot of opportunities always available to really showcase the kind of efforts that we undertake as land managers so that the public can really get engaged within that work. So, oops, sorry, there we go. So now that I have hopefully sold you on why prescribed grazing, I'll move on to more of the specifics of our pilot project. So this past June in 2024, the City of Toronto's Urban Forestry Department brought 65 goats to graze the meadow at Don Valley Brickworks Park. So after years of project planning, we were the first municipality to pilot comprehensive urban goat grazing in Ontario. And I really hope that the project demonstrates Toronto's commitment to the protection and enhancement of our urban ecosystems and our commitment to innovation in how we manage them. And I will say it's been really nice to see that other land managers and municipalities throughout the country have really shown a lot of interest since learning of our project, and we're seeing other projects take off as well. So for context, Don Valley Brickworks Park is a very popular and busy natural environment restoration park located in the Don River watershed. The Don River watershed is one of the most urbanized watersheds in Canada with over 1.4 million residents. And the park is one of Toronto's flagship natural environment restoration projects, restored from a former quarry, and really is showcasing restoration and habitat diversity with meadow, forest, and wetland areas all throughout the park, which each have their own extensive native plant communities. The focus for our grazing pilot was on the main meadow node in the central bowl of the park, and I'll have a good aerial shot to show so you'll get some context there. And the grazing site was approximately 3,000 meters squared, which is about half of the total central meadow. So in terms of duration and stalking rates, our pilot ran for 2.5 days total with over 65 goats. So now, while this might seem like a short time and a large number of goats for a relatively small area, that was chosen for a reason. And again, I wanted to mimic those evolutionary pressures of of large herds I mentioned earlier as much as possible. So I wanted to go with a high stocking rate to better impact the site. And I also wanted to reduce the timelines, logistics, and resources um, required for having a small number of goats on site for a longer period of time, where you just don't get that same impact like the evolutionary mechanism. And you have to have a lot of the logistics in place for having the goats in such a populated site for a long period of time. So to keep the stocking rate high, fast, and intense allowed us to maximize efficiency and also mimic those evolutionary pressures. And our pilot centered around a number of specific management goals, including addressing that woody encroachment I mentioned earlier. We had a variety of woody species encroaching on the site, mostly buckthorn, but also cottonwoods and willows. Addressing herbaceous, non-native, invasive, and non-compatible plant species on site, increasing native species regeneration and diversity. Um, a bit of a unique one was finding new ways to manage a site with very high public pressures and use patterns. So having as many visitors as we do on site can limit our management options for a sensitive natural environment area. For example, I had to make the choice to stop mowing management here, which was our initial management plan, because as soon as I would mow the meadow, people would mistake the area for just a typical mown grass field in a park, which would result in picnicking, sports, a lot of off-leash dog activity, which was all causing a lot of damage and trampling. So I really needed to find a new and unique tool that would fit this site in particular. And lastly, prescribed grazing really represented a really valuable chance for public engagement and education, which was really at the forefront of the project planning all the way from the beginning, along with a really strong commitment to animal welfare and public safety. So just very quickly, some of those logistics on animal welfare planning here is they're really critical to our success. That started with our choice of contractor. We used a company called Goats in the City. So these goats do not belong to us at the City of Toronto. They're from Goats in the City, who is a contractor that is just doing prescribed grazing, and they're based in Southern Ontario. Um, they only use their goats for prescribed grazing and nothing else. So the goats will live out their full lives at their farm, other than the various grazing locations they work at. And they don't provide meat, milk, fibers, or any other consumable products. And for the grazing work itself, grazing in a herd is completely natural behavior for the goats, so it's not stressful for them. It's what they'd be doing at home, and they're kept in their family groups, including babies with their mothers. We use a double perimeter fencing system to make sure that they're safe from predators and from the public, and that the public is safe as well. And made sure that they had free access to water and sun and rain shelter at all times. The goats also had 24-hour in-person care and supervision, including overnight GPS herd tracking. Vets were on call. We also had City of Toronto enforcement officers that were able to come to the site to support us, especially to make sure that any visitors had their dogs on leash at all times. So really overall, you could see how comfortable the goats were. They were at work, sure, but really just going about their normal and natural behavior of eating with their herd. So I'm going to put in some drone footage here of the site. And first off, you can, here we go, let's get this going. You can really see the landscape context of the park right in the heart of the city and our ravine network. So swooping in on the grazing site in advance of the grazing, you can see that some of that woody encroachment, though it's difficult to see all the small buckthorn sprouts throughout. Now in the during shots, you can see the 3,000 meters square that we set aside for grazing is about 1/2 of the total core meadow area in the park. There's that double perimeter fencing on either side of the mow line. And then the area was divided in half again with a division fence, with the goats grazing 1/2 each day, which helped keep them focused on grazing and less on curious exploring. Overall, you can see how effective the herd was at grazing down the entire delineated area for them, with both herbaceous and woody species being targeted. Now you can see that there are still some large woody specimens that are just much too large for a goat to tackle. But that's kind of a first year problem because as we continue on with this, It's the smaller sprouts that are really the biggest concern for ongoing preservation of the meadow. Now, so what were some of our preliminary observations? So one of the questions I really get asked the most at this stage is, was the pilot a success? And the answer is really a resounding absolutely yes, but with some important nuance. So at this stage, it's really important to remember that some observations are more immediately obvious on a short time scale, like the impacts to woody encroachment that we saw and some really fantastic outreach and engagement metrics, and just the overall capacity for the goats to graze the entire site. But other things will likely take some more time to see. So, like native invasive species regeneration over time. So, that will take some time to observe the species changeover on the site over time. But with that caveat, though, the project could definitely be called a success based on our initial observations. So, choosing to graze half of the site during the pilot really allowed us an ungrazed sort of control area for comparison in our first year of monitoring. And it's worth noting here that we worked closely with the Toronto field naturalists on a really great volunteer monitoring protocol and also set up a number of photo monitoring plots for really good quality monitoring data over time. But overall, the goats were successfully able to complete their grazing of the full 3,000 square meters in the time set out for them and preferentially targeted the woody species. One particularly striking observation was just how effective the goats were at targeting buckthorn, which was a huge win. Goats will eat in their order of preference, and buckthorn was definitely their number one target. You can see in the video on the right that even after they would eat the leaves and twigs, they would move on to eat and rub the bark, which effectively girdled any buckthorn that was too large for them to eat all the way down to the ground. And this was even evident on quite large buckthorn plants. So conversely, though, we were also able to preserve and retain the native common milkweed on the site, which is low on a goat's eating preference list, and which that should help with future regeneration of that really important native species on site. And so one of the questions that often comes up is like, how do you get the goats to eat the plants that you want? And that's not exactly what's happening. The goats will eat just about anything, and they will eat in their order of preference. And so in some ways, you're relying on the fact that what's really great is that their order of preference kind of goes buckthorn down, right? So these are species we don't want to hit. But it also takes the knowledge of um, the staff, project manager, and the eco shepherd, whoever is actually running the goats, to really know when to move them off an area. For example, when they're getting all the way down to the list to the common milkweed, and we want to retain the common milkweed, so it's time for the goats to move on to a new area. So lastly, I did want to pull out those outreach and engagement metrics, which were overwhelmingly positive and really one of those early stage, very obvious successes of the project. So in addition to post-event opportunities like this one, we had a lot of engagement opportunities during the event itself to really bring the public in on what we're doing. So over 1,300 park visitors took part in staff-led talks throughout the 2 days, and others could learn more informally from educational sites installed around, or educational signs rather, installed around the site, mostly on the fencing, or online from the media, social media posts and the website. It was a really good opportunity for people that like to engage in more formal learning opportunities to have the city-led talks, but also the people that would get on site and their first and only question is, I don't want to talk to you, where are the goats? We had a good opportunity to still have a lot of chance for education with the signage up on site and also just being back with the goats and answering questions all day to the public. So in terms of media, the project was very well received and we generated over 143 mentions from local and national media outlets and close to 140 million online impressions, with both of those metrics growing since the event. Those are just the metrics of the 2 days of the event. And so since then, we've obviously had a lot more uptake, both from media and the public separately. But what was really great and something you don't see very often was that 100% of those mentions were considered positive sentiment. So, including public interaction in the field, the media, social media uptake and comments, which I think anyone involved in municipal land management activities can appreciate. 100% positive sentiment is a real win. People were excited to see the goats. They were happy to be there. They were already asking when they were going to come back. So very, very positive in terms of public sentiment. So then what about the future and our next steps? So given the initial success of the pilot in 2025, we're aiming to move to a rotational grazing model, which means we'll be shifting to the other ungrazed half of the meadow in 2025. We'll also be continuing our monitoring protocols with Toronto field naturalists and photo monitoring so we can keep observing how the grazing influences the meadow over time. Overall, though, I'm getting ready to bring the goats back in 2025, and I'll be continuing to spread the word about the project. Um, I'd really like to thank you for having me here today. I hope it helps communicate the City of Toronto's dedication to innovation and working at the forefront of natural environment management. And we're excited and proud to be the first to bring prescribed grazing to Ontario, and really happy to see other land managers adopting projects of their own. So thanks so much.
Awesome. Thanks so much for that, Cheryl. Really great to hear about this project and learn more. Um, those positive metrics was awesome to hear, but I'm not super surprised. Who could hate some cute little goats just doing their thing? Sweet. So moving along, our next presenter is tuning in from Edmonton, Alberta. I'm glad to introduce Paige Kuzmarski, Biocontrol and Communications Coordinator with the Alberta Invasive Species Council. And Paige graduated with a bachelor's degree in biological sciences from MacEwan University, where she was first introduced to invasive species, and that was through research projects around garlic mustard and forest tent caterpillars. Soon after, she started various positions with Alberta Agriculture and Alberta Environment, as well as parks over the next few years. And then eventually she joined Alberta Invasive Species Council as kind of their Jill of all trades, running the Biocontrol Release Program, increasing Alberta Invasive Species Council's social media presence, and general invasive species projects. She continues to foster her love of the outdoors within this role and hopes to assist in educating Albertans on invasive species and their management. So for the next 20 minutes or so, Paige will highlight AISC's work and the history of biocontrol efforts in Alberta. And with that, Paige, I'm going to pass the torch off to you.
Thanks for tuning in today. Again, yes, you nailed my last name. That doesn't usually happen often. So I'm Paige with the AISC, or the Alberta Invasive Species Council, and we'll be chatting about the biocontrol program. I didn't know what the audience would be like today, so I thought I'd touch on invasive species a little smidge. We know they're non-native organisms that cause harm to our health, economy, and environments, and they're very costly, which we all, I imagine, are a little bit penny pinching. It always happens, especially nowadays. But invasive species are considered the second greatest threat to biodiversity after habitat loss worldwide. They reduce the overall diversity and ecosystem function when they're present, which is really environmentally costly. So globally, impacts from invasive species cost about 423 billion per year. In Alberta, that's 2.1 billion per year, which is about $480 per person. So the majority of those costs are associated with rangeland weeds, and that's through control costs, crop yields, property value, recreation, so much more. You can see on the screen here, I put a picture of flowering rush in Lake Isle, just west of Edmonton. That is 17 kilometers thick from the shoreline of flowering rush. You can walk on it, and I have. So It's pretty impressive. This plant interferes with water availability, dissolves oxygen for fish, recreational activities with increases in algal blooms, and pretty much totally impassable areas from those maps. Really, the story I'd say, though, is that these ecological effects translate into economic effects. So with invasive species, we know that prevention is the answer, but when we don't have that option for management, we really need to look at more cost-effective solutions to control the spread of these species. There are many available solutions. We just heard about one, and they're also costly, but some of those are herbicides or chemicals. This is by far the most common means of controlling invasive plants. This requires ongoing labor, though, equipment, the herbicides themselves, and then not only that, this is a monthly, sometimes yearly expense. We also have mechanical, which is the most labor intensive, mowing, burning, mulching, competitive planting, hand pulling, cultivation. This requires repeated treatments and operation costs, and again, is a lot of work. We also have grazers, so we heard about those goats. Invasive plants should never be considered forage for livestock, but there are some instances where animals, usually those sheep and goats, can be trained to eat certain species or have a preference for them, like we heard about. There's always chance of off-target species. Animals may be separating from the group if it's not within a park or a fence, and then again, labor to manage those animals. And then we have biocontrol. So part of the reason that invasive plants do so well is because they lack natural predators in their new habitat. So introduction of a natural pest, often from where the invasive plant originated, can be very effective and saves the wallet in the long run. So an initial investment in research is expensive, as well as the testing and release is required for that. But otherwise, these agents can work passively for years. They minimize environmental damage to other species, as they're extremely specific to the target that they're researched for. They can also work in areas that are difficult to access or maybe have legislation against prohibited spraying. Sometimes by water, it's a lot harder to spray, but it really makes them sustainable kind of long term. So biocontrol is not the only option available for invasive plant management, and definitely not the most common one, especially since not all plant species have biocontrol available. So there's really no one size fits all with control. So we have to use kind of an integrated pest management approach. And that varies with each pest and depends on effectiveness, timing, economics, location, and a bunch of other fun factors. But why we've come here all today is to hear about biocontrol. So what specifically is biocontrol? You can see on the screen, it's used to control and suppress populations of pest species using the invasive plant's natural enemies. So usually we use insects or pathogens from the plant's place of origin. The goal is to reduce the invasive plant's population to below damaging levels, which can be defined as either environmental or economic levels of damage. So the AISC uses host-specific insects. There's 2 agents on the screen there to control invasive plants in Alberta. These agents used are proven and tested for years prior to release to ensure that their target is only the pest species of interest. These agents are great. Can't say enough good things about them. They're self-sustaining and really require little input after they're released, making them an ideal tool for pest management. This has not always been successful with biocontrol releases. There's a few examples that I'd like to point out, but over the years we've learned some lessons. And I like to compare it to Goldilocks and the 3 bears. We have 3 examples of biocontrol here to illustrate really what happened until we got it just right. So first, we tried the infamous cane toad, which was definitely too hot to handle. 102 toads were brought to Australia and released in 1935 to control cane beetles in sugarcane crops. Unfortunately, instead of beating the pest, they became one and have proved ineffective in controlling pests in sugarcane fields. They can grow to the size of dinner plates and have huge appetites for native plants and insects, and they're capable of poisoning predators as they had this toxic substance that they exude that's deadly to humans and other animals. So those cane toads continue to spread across 2,000 kilometers from the site that they were originally released, which is wild. Then we tried something too cold, the rosy wolf snail. So this one was introduced to Hawaii in 1955 as a biocontrol agent for the invasive African land snail. Now, this cannibalistic snail has pushed native mollusk populations to the brink of extinction since it is much faster than native snails and slugs, which is a funny thing to say already. And then it uses their slime to actually track and hunt the prey. Then we found our Goldilocks. We found something that was just right, and that was the hound's tongue root weevil. So this agent was released in 1997 in Canada and was so successful in southern Alberta that in 2021, we actually decided to stop releasing this agent as populations of hound's tongue plants actually commonly already had this agent present. So that's a great good news story. Although we had some mishaps, biocontrol is a lot more rigid in regards to the approval process now. Import and release of biocontrol agents in Canada is very regulated. The insects are studied rigorously and really go through a robust approval process through the Canada Food Inspection Agency, or CFIA, to ensure that there's no risk to off-target species. So this process takes quite a while, about 10 or so years and millions of dollars. There's essentially no concern of off-target damage for any of the agents that are released, though. So the process on this graph here really begins with submitting a petition for release. It's then reviewed by a biocontrol review committee. They submit a recommendation to CFIA to approve the agent or not, and then the agent is pushed to testing in the lab and then in the field by Agriculture and Agri-Food Canada. So we have covered our bases with biocontrol basics. We can dive into the AISC's Biocontrol Release Program. So it started, about 25 years ago now, in 2001, as a collaboration between the Weed Biocontrol Research Team at Agriculture and Agri-Food Canada, where they do the research and the testing, and then several agricultural fieldmen in southern Alberta that do the releases and field work. So it's a really, really unique program that way. And it's entirely funded by participants and operated by us at the Invasive Species Council. It's a service for invasive plant managers and owners to purchase agents in conjunction with our expert consulting, if you will. The first target species for this program was leafy spurge, which is now the bane of my existence, but it's a fun one. Since starting with leafy spurge, the program has expanded to working with over 39 different organizations, whether that be municipalities, individual landowners, all the way to Alberta parks. We supply biocontrol agents for their invasive plant populations, and I would argue that this number has increased too. From the ongoing support and over the years, we've been able to offer additional agents for release, which includes hound's tongue, Dalmatian toadflax, spotted, diffuse, and Russian knapweeds. So since starting the program back in 2001, we have released and monitored biocontrol agents at over 1,500 locations in Alberta, and that number definitely grows every year. Here's just a little glimpse of what those agents look like that we offer in the province. Knapweed root weevil is on the top left screen, and knapweed seedhead weevil on the top right. The seedhead weevil kind of lays the eggs in the flower heads, and the larvae eat the seeds, whereas the adults feed on the leaves of the plant. Then we have the root weevil on the top left again. They lay their eggs in the root crown, so just below the soil surface, where the larvae actually tunnel through the taproot, and expose it to infection. So these agents can be used together as they attack different parts of the knapweed and will not compete with one another. So that's pretty cool. We have Dalmatian toadflax stem weevil just underneath there. Again, another weevil. There's a lot of weevils for biocontrol. That's on the bottom left. They leave a distinct shot hole pattern. It's very circular, very distinct on the leaves and stems after emerging that actually stunt the plant growth. Then just to the right of that, the bottom right, we have the Russian knapweed gall wasp. This guy lays eggs in the plant stem where they create kind of this tumor-like growth or a gall, which draws nutrients away from the plant and reduces its ability to grow. And then the top right, we have leafy spurge beetles, which is the one I am most familiar with, and definitely the one we deal with the most. So I got involved with the Biocontrol program in 2021 after the previous coordinator moved to a different position. We didn't really have a lot of time before the season began, so we only released one agent that year, being leafy spurge beetles. As I mentioned, leafy spurge was the first species that was targeted for this program. It's also classified as a noxious weed in Alberta, so it must be contained and not spread. Leafy spurge is not only difficult to control, but it's also harmful to most livestock, an irritant to human skin from that milky sap that it produces, although I've never had any irritation. So it's very prominent in southern Alberta. Basically everywhere you look, you'll see a field of it. This is where most of our collection sites are and majority of our releases are done. So, of course, leafy spurge beetles are used to target leafy spurge. There are two species that we use. Hold with me while I butcher these, but Aphthona lacertosa and Aphthona nigricutis, basically black and brown leafy spurge beetles. But these beetles both feed on leaves and flowers of leafy spurge and limit the plant's ability to grow. They're really small, about 3 to 5 millimeters, and can lay around 200 eggs in the soil. They'll hatch and burrow in the soil where the larvae actually overwinter and feed on the spurge roots, which is where the majority of that plant damage comes in until they emerge in the spring. The collection of these guys occurs at the end of June as adults. The information page on the side there on the right is just a quick few pages that we created for the target species. Of course, leafy spurge in this case, the biology of the agent, and a quick guide on how to prepare for a release and how to move the beetles once they've actually established after a few years. And we have these how-to sheets for each agent that we release. I included a little video of how we actually collect the agent. I don't know if it'll have sound because I'm known to not have that, but during the summer, of course, we're in a field of leafy spurge. We collect the small beetle using a sweep net. You can see there's already some in there, so they're quite tiny. And we really just drag it over top, back and forth over top of the plants. And this has to be in sunny weather. If it's raining, the insects won't be up. Then we use this collector. We basically dump the net in the top. There's a mesh kind of basket within. And when it's sunny and hot, the beetles are active, so they jump around and jump out all the way down, funneling into that collection jar at the bottom. So we do get some insects that aren't leafy spurge, but majority of those guys are the leafy spurge beetles. You can see they're tiny, there's a full order, and there's us releasing an order on a patch. Oh, did I restart it? Okay. So then after collecting, we, of course, dump the agents into an infestation of leafy spurge, like you saw. Those sites, we require kind of specific site properties for good establishment. All the ones on the screen here are kind of an ideal situation, but you can have a couple of these and it'll still should work for establishment of a beetle population. We consider establishment at least one beetle the following year. So that would be full sun, just away from the tree canopy, a patch size of about 20 meters squared, east or south facing slopes, which provides shelter from winds, a buffer zone of 10 meters from herbicide treatments. We usually avoid floodplains or the high water mark, as saturated soils are really detrimental to the beetle larvae. And then we can release on the edge of a patch to monitor the spread within. They'll create kind of this haloing effect from the point of release. So it's pretty distinct after a couple years. That's kind of it for collecting and releasing the beetles. The other agents we release have similar collections using the net, or we actually hand collect them off the plant. But the biggest difference would be in the time of collection. So whether that's early spring, midsummer, or fall sometimes. But let's talk about our results from the field this past year. We had released only leafy spurge beetles and spotted knapweed agents. We had a total of 84 orders compared to 2023. We had 72, so a good 12 extra, made for a longer summer, but always get a tan out there, right? These orders were placed by 18 different collaborators. So again, municipalities, organizations, and various landowners. You can see some of our release sites for those agents. We were in Waterton, and I think this was in Cypress County for the leafy spurge. Oh, here's a map, of course, of the 84 orders across the province. We released as far north as Fort Saskatchewan, just outside of Edmonton there, and then as far south as Waterton National Park, which is always a favorite. Overall, biocontrol is extremely useful and can make a huge difference, especially in areas that herbicides or other methods may not be the most effective tool. In this example, you can see Pincher Creek. It's a southern county in the province. Within 5 years of biocontrol for leafy spurge release, a completely infested field of leafy spurge has dwindled to almost virtually no plants. And that's all from the release of those beetles. So this is not the case always, but this was the best site for them and definitely a win. Biocontrol is again meant to bring the populations down to those manageable levels. So now managers can go in and manually pull or spot spray and use alternative tools in the toolbox. And then there's also always new things coming down the pipeline for the Invasive Species Council. So we don't do a lot of the research, we do the field releases. However, we have a stake in some of these projects. So common tansy is one that's coming down the pipe. They are stem mining weevils. They are ready for releases this year, pending CFIA approval, which is really exciting. Tansy is very common in northern Alberta, so I feel like that'll be a big one. It's not yet ready for distribution to the counties, but for releases outside to establish those collection sites and populations. Then we have yellow toadflax weevil. This is going to be a gall mining weevil. The lab rearing stopped a few years ago, but releases have shown significant reductions in yellow toadflax in the 2015 sites that were released. They did note, Agriculture and Agri-Food Canada did notice a less than 5% wasp parasitism rate to the weevils, but it's a pretty small number, so they're not too concerned. Then we have early releases of Russian olive gall mites and oxeye daisy stem moths in BC and southern Alberta from 2023. They actually survived our extreme winter conditions from that year, which were a consistent minus 40 for quite a few weeks. So they are here to stay, hopefully. Rearing continues for those guys for further releases and monitoring. Other provinces may focus on other agents like flowering rush that we saw at the beginning. We have a vested interest in flowering rush, but BC got the sites. There's a weevil and fly. Whereas in the east, we have Phragmites, which is very common. I know there's a moth coming down too, but this is really what we're working on in Alberta. And I think that's all I have for you. So if you're interested in any orders, I feel like the audience is all across the province. I only deal with Alberta biocontrol orders, but let me know if you have any questions. We'll keep those to the end, but follow along with us on our social medias because I do post a lot about our biocontrol there.
So that's great. Thanks so much, Paige. Really cool presentation. That Pincher Creek before and after, that was crazy to see. Okay, thanks so much, Paige. I'm going to move along to our final presentation. But yeah, so our last but not least, we have Emilia Stepinski tuning in from Virginia. And Emilia's an environmental engineer and geospatial technician lead with Ramboll Group. So Emilia has 14 years of experience in geospatial analytics, remote sensing, and data science and visualization. Her expertise includes developing AI models for Earth observation data analysis, such as habitat classification, invasive species identification and biodiversity monitoring. As a geospatial team lead, her role is to ensure the continued development of Ramboll's data analytic capabilities using machine learning and deep learning methods for imagery analysis. So her presentation today will explore how drone imagery combined with AI-powered imagery analysis can revolutionize the management of invasive species, plant species. Specifically, her presentation will showcase two case studies identifying giant hogweed both in the UK and as well as New York State. So I'm going to stop here, and Emilia, I'll pass things off to you. Looks
Thanks
great.
again, Chris, for that introduction. As Chris said, I work with Ramboll, which is a global engineering and consulting firm. We work across many markets, but I'm in the environment and health market. And so my team works on utilizing remote sensing and AI to support effective environmental monitoring for our clients. So it's truly a pleasure to be here with you today. Just a quick agenda for the presentation. I'll quickly touch on the challenge, although I think Paige covered it pretty well. And then I'll skip over to talking about the technology that we're using in terms of drones and AI. I'll go over the case studies, and then I'll wrap it up with some general considerations for if you're thinking about using drone imagery and AI for invasive plant species monitoring, and then finish with some conclusions. So Paige covered the challenge, and of course, I feel like I'm preaching to the choir here when it comes to discussing, challenges around invasive plant species. But needless to say, it's a major driver of the nature crisis, and in one way or another, invasive plant species and invasive species in general can cause biodiversity loss, ecosystem disruption, economic impact, and impact human health as well, just to name a few. But there's also specific challenges around monitoring invasive plant species and their impact. So the other two presentations focused more on the management, and I'm talking more about monitoring in terms of identifying where, for example, invasive plant species are and where you should even be targeting your management activities. So often when you're in the monitoring phase, you have really large areas of concern that are difficult to traverse on foot. And prioritizing monitoring over large areas is challenging. There's inherent safety risks. It can be difficult to kind of quantify change over time if you don't have that digital record, such as imagery, to show the impact of management activities. And monitoring can also be time sensitive. You have certain times of year and certain pressures, drivers to complete monitoring activities, and it requires various resources and knowledge. It can be costly. So these are all general challenges of monitoring invasive plant species. But of course, technology can help, specifically collecting drone imagery and using AI models. So that's what I want to focus on today. There's generally 4 stages to a project when we're looking at how to generate environmental insights from remote sensing imagery and AI imagery. The first stage is to collect remote sensing imagery. So when I say remote sensing imagery, I mean imagery collected from a drone or an aircraft or satellite as sort of like a top-down image. So like what you see in Google Maps or something like that. So as opposed to, like an oblique image from a drone or something. So top-down imagery, there's lots of different sensors that we can use to collect imagery. So choosing the right sensor to match the problem and the scale of your site is an important first step. Once we have that imagery, we can build tailored imagery analysis pipelines and AI modeling pipelines to analyze the imagery depending on what question we're trying to answer. So if it's where's the location of, certain tree, or what is the land cover, or, in this case, where are the locations of certain invasive species. So back in the office, at the desktop, we build these models, and then we work with ecology and biodiversity staff to really interpret the data, the analysis, and visualize the data in a way that we can make actionable decisions in terms of management, which is really the last step. So how do we take all of that data and data analysis and interpretation and create a management plan that's targeted and efficient? So one important note that I want to say here is that these technologies, drone imagery, AI, have been just significantly evolving in the past, several years, 5+ years. Drone imagery is now really accessible, and there's, 1,000 satellites collecting imagery every day. There's all sorts of, methods to collect imagery. And also, as everyone's aware, there's really recently been a really big rise in the use of AI and access to computing power. So it's actually one of the big driving forces in today's society. So these technologies are really like actively evolving. So this very sort of simple workflow that I'm showing here, can change quite rapidly. I can imagine lots of technologies for actually using drones and AI for the targeted management activities themselves, or how do we improve this pipeline that I'm showing on the slide to be uh, used to be accessible to more people, really. So with that, I am just going to jump into the case studies because it's great to see it in action. So I'll present two case studies today. They're both for giant hogweed. The first one is in the UK. So this was a pilot project that we did with National Highways in the UK. National Highways operates the highway network in England and is required to manage invasive plant species along the road corridor. So this is a big problem for National Highways. And giant hogweed in general is a big problem in the UK. It was first introduced as an ornamental plant and now, is an invasive species in the country. So as many of you know, when giant hogweed grows to full height, it can be 1 meter to 5 meters tall, as you can tell in this image here. When it's blooming, it has this really big white flowering head, so it's quite distinctive, particularly when you're talking about collecting top-down imagery. And it can be quite nasty if you come into contact with it. The sap can cause burns, so people have to take extra precautions. So for this pilot study, we collected drone imagery, very high resolution drone imagery across approximately 0.6 square kilometers of a natural area that was adjacent to the road network. And this imagery had a resolution of 2 inches, about 2 inches per pixel. And the way it works is that the drone flies in kind of a regular pattern, over the site, collecting images, and then those images are stitched together into one orthomosaic map covering the entire site. But I do want to highlight that kind of these brownish orange areas in the imagery is the giant hogweed. So the timing of this imagery capture was late in the season when the giant hogweed had already gone to seed. So it's not that white flowering head that I was talking about before. On this next slide, you're seeing our modeling results from our AI model. So if I skip back and forth between these two slides, you can see the orange is the results of our modeling. So I'll spend a minute here talking about the process to actually go from imagery to these polygons that you're seeing, these orange polygons, which is the delineated areas of where giant hogweed was identified with the model in the imagery. So the first step is to create training data. So AI models need training data, which are basically examples of what giant hogweed looks like, so that then we can train the model on those examples, and then we deploy the model on the entire area of imagery, so imagery that the model hasn't seen, and then it predicts where it thinks that there are other locations of giant hogweed. So over time, with enough training data, you can actually create a model that generalizes pretty well, and it can be applied from image to image, from site to site. And that's really where the benefit of AI comes in, where it really starts to shine, is where you can just have a ready-made model and apply it to new imagery and have a map of the locations of whatever invasive plant species you have in question. So this next slide is just more of a zoom in on some of the imagery and some of this area of giant hogweed. And if we jump to the next slide here, I'm showing again the modeling results from our modeling effort. And what you'll see is in the lower left-hand side, there is giant hogweed that's been identified in this dense vegetation. So you can imagine if you're walking down this road, you're going to easily see all this giant hogweed, but you may not, walk all the way in here through this dense vegetation to see that there's actually giant hogweed within here as well. So that was the pilot that we did with National Highways, and it was an interesting site to do this pilot on because the giant hogweed was so prolific, like it was really widespread throughout the site. But I know that that's not always the case, and in fact, what can be more challenging is identifying, when invasives are just starting to appear and catching the management at that point, as opposed to, waiting until there's an infestation. So this next case study will highlight perhaps maybe a more common scenario. This was a project we did with the New York State Department of Environmental Conservation. And the NYDEC has an active giant hogweed program. So we teamed up with them to pilot how these technologies can help monitor and assess giant hogweed in New York. So together we identified this natural area that's about 1.6 square kilometers large in kind of close to Springwater, New York. And this is an area that's owned by New York State, and it's managed by the Department of Environmental Conservation. You can see this like oblique drone imagery here showing a part of the site. And some of the characteristics of the site are that it's really quite difficult to traverse on foot. It's very swampy. There's areas of dense vegetation, and the staff at NYDC were concerned that there's unmapped, unknown giant hogweed throughout this site that they just didn't know about because they aren't able to traverse the entire site every year and find all of the new giant hogweed. So for this site, we collected RGB drone imagery in May and June, and we were able to capture giant hogweed at that beginning of the bloom season, so when it has that white flowering head. Here's some close-up images of the top-down drone imagery. This is kind of zoomed in, right? So imagine this level of imagery, but across the 1.6 square kilometers that we collected imagery for. So once we have this imagery, we go back to the office and we got to work developing a model that would be able to easily sift through the entire image and find all the locations of giant hogweed. So let's see. Yeah, I wanted to touch on the training data part. You can see the little blue polygons surrounding the giant hogweed in this image. That's the first step in creating an AI model. We go into like a GIS application and we draw polygons around a subset, a small area of the imagery, showing examples of giant hogweed. We then train an AI model and then deploy the model on the entire image. So on this next slide, these red dots represent where our model predicted giant hogweed locations. And on the sides here are just kind of zoom ins to see what those locations look like and what the imagery looks like. When we showed these results to NYDC, they were really excited because they told us that normally at this site, when they do management activities, they kind of walk up this corridor along the waterway, but they don't often go into deeper from the waterway to investigate whether there's any giant hogweed. So when we showed them that we actually had found that there's giant hogweed here, it was very exciting because that was a patch that they hadn't known about. If I just skip through the next couple of slides, it's just showing some examples of kind of the individual plants that we're able to identify with this method. And here's that big patch that I was talking about. So with this pilot study, we also did a ground truthing work where the NYDC staff went out to do their regular management activities, but they had our imagery and they had the modeling results on their tablets that they were using to collect data. On the left here, these paths, these lines show how they were walking through the site and how they were, navigating to not only using their own site knowledge, but also navigating to the areas where we had predicted locations of giant hogweed. And of course, they make a detour to come visit this new patch right here. And on the right, the pink polygons show the field data where they notated areas of giant hogweed in the field. And you can see that it lines up quite well with our red points. I think the kind of slight shift is because of slight GPS data issues, but you can imagine these sort of aligning if your GPS has the same accuracy. So I'll just touch on a few considerations that you should have when you're thinking about using drones and AI for mapping invasive plant species. First of all, there's obviously the logistics around collecting drone imagery. You have to consider weather and then costs and just the time it takes, airspace regulations, and obviously having a trained pilot to collect imagery. You also have to consider just the um, collecting imagery at the right resolution that you need to be able to see whatever plant species of interest you have. And along with that, if you're interested in something that grows under a canopy, then maybe using drone imagery isn't the best option because you won't be able to see that. That won't be very visible. The other thing that's important is thinking about the timing of collecting your imagery. On the right here, I'm showing two images collected like a month apart at the New York State site. And you can see just the difference in how obvious giant hogweed is, those white flowering heads popping up in the later imagery. So the last note here is that obviously AI models take time to train. So, and they need a lot of data. So the benefit really of using AI is when you have a lot of area, a lot of data, and are really looking to make monitoring impact on a large scale in a situation where you just couldn't feasibly do it with boots on the ground. That's really when the benefit starts to shine. I just have two more slides. I think I just wanted to highlight that it's very exciting, all of these applications for invasive plant species monitoring, but there's so many different biodiversity monitoring applications when you're talking about using drone imagery and AI. There's obviously change over time analysis, vegetation health trends, monitoring restoration and rehabilitation, classifying habitats, and just general biodiversity monitoring, which is a lot of organizations starting to be really interested in understanding and quantifying biodiversity at their sites. So I wanted to highlight one recent project that we worked on where using drone imagery, we were able to create an AI model to really classify the entire project area with specific kind of biodiversity parameters, looking at locations of wetlands, looking at different tree types, looking at locations of dieback, uh, understanding the forest structure in terms of gaps between canopy, identifying where there's algae growth on the lakes. So all sorts of these parameters, these are the types of things that you can start analyzing and really quantifying when you're using drone imagery and connecting it with AI. Just some final conclusions. This first arrow here is a quote that one of our clients made, which is that, we're making maps we've never been able to make before. This is, of course, because we have all this data and imagery that and we're able to analyze this imagery in a way to create maps and visualizations that really help in the decision-making process. And when it comes to invasive species management, I think these technologies can really help creating an aggressive monitoring strategy and management strategy for invasive plant species in a way that you can really focus on a specific area over a specific time and really have a good understanding and quantification of the invasive plant species problem. And it can also help with identifying things early, which helps with budgeting and cost control and just before things get, out of hand, like with the New York example, finding new areas that were, unknown before. And my final point here is by collecting drone imagery and doing this analysis, you're really creating a permanent sort of digital record of the land that lets you see the impact that you're having over time and lets you analyze and understand and communicate the success of management strategies. And that's it. Thank you, everyone.
Awesome, Emilia. Thanks so much for that. I know in the last handful of years, drones and AI have really blown up. So great to see how we can use that to manage invasive species. Okay, thanks everyone for sticking around past the hour here. We're gonna do a few questions. I just want to respect all yours and our speakers' time, so we'll tackle a few questions per speaker. I'll invite our speakers back up to the stage. I guess that's just turning on your camera. So let's see. First one is for Cheryl in the targeted grazing. You mentioned all the accommodations for the goats and animal welfare. Were all these features supplied by goats in the city or by the city of Toronto itself?
Yeah, so the city supplied the external fencing. So I mentioned that we had two layers of fencing. The external fencing was like a construction fast fence that the city supplied. And the internal fencing was the fencing that the goats have grown up with since birth and what they're very used to. All of the rest of the equipment was provided by goats in the city. The city of Toronto also did all of the outreach materials. So like none of the actual like animal welfare stuff. So all the signs and our info tents and all of that stuff, that was all city. But in terms of the actual animal welfare question, other than the external secondary fence, everything was supplied by the contractor.
Awesome. Cool. And just a question about that. What about a province or jurisdiction that doesn't have kind of a goats in the city organization and they wanted to start a targeting grazing? How would they go about doing that?
Well, I mean, that is a very good question. I've had this on my radar as a project that I've wanted to get off the ground for a decade, and the biggest hurdle to that was finding an appropriate um, herd and eco shepherd for grazing. So it's not necessarily, and I get this question a lot, I have goats, can I do this? Um, the answer isn't no, but it's a very, very weighted yes, but. So there's a lot of knowledge and experience and understanding to ecosystem management with goats, not just having goats and putting them in a field. So that is a little bit challenging insofar as if you don't have contractors available for that work that are specialized in grazing. It would take a lot more time to actually learn how to properly implement a grazing protocol as opposed to just being able to hire a contractor that is experienced with that.
Makes sense. Sweet. And I'll just do one more for your presentation. You mentioned having grazing along with other management strategies, and are there concerns about maybe herbicide being used previously and then goats coming into graze? Is that a concern?
Yep, and I mean that's again, you have to plan these over a long period of time. So we stopped using any kind of chemical control methods within the grazing area at least 1 year before the goats came in. Chemical methods are still used within the park, but not within the grazing area. And so that was part of the agreement, was that it had to be stopped at least 1 year in advance. And that's what the protocol was with the grazing company. So we actually hadn't done any chemical control within that area for well over a year, but that was the follow-up. So yes, it does have to be considered. If you've recently treated an area, you can't bring the goats.
Awesome. Thank you. That's great to know. Let's see. Okay, we're going to move on to questions on the the biocontrol now. Thank you, Cheryl. Yeah, I don't want to take up too much time from everybody here. Let's see. We have one. When biocontrol is a success and the target becomes eradicated, what happens to the agents? Do they move on, or do they just kind of die off?
Totally. So they're again self-sustaining, but yeah, once they don't have food or habitat, they just kind of fall off with the plants. So you don't need to go back and move them again. Usually the case, if you have a bigger population somewhere else, you would wait till they're like have really decimated the infestation, and then you can go in and move them around. But if you don't have anywhere else to move them, you can essentially just let them go on their way.
Let's see. And in Alberta Invasive Species Council, the Biocontrol Project, does that primarily target rangelands, or do you do other native ecosystems?
Totally depends who orders the agents and depends what their site looks like. I would say primarily it's rangelands, but we also have a lot of crown land that we manage. Lots of the fieldmen for the counties have different areas or help landowners. So majority of them would be rangelands, and then as well close to water bodies because it's really hard to spray near water.
Awesome. And I'll just do one more question here, if that's all right. So how many do you need to release of each agent to make sure they establish? And is one order enough, or do you have to keep doing it year after year?
Totally depends on the size of your infestation. You could just do one order, and each agent is a different amount. So say for leafy spurge, we put them in that vial, but we don't individually count them, whereas the root weevils we do individually count. Either way, it's a certain amount for each agent, and then depending how big your site is, you could want to release more. You also would want to see how long it would take for them to establish. So again, an establishment the following year, you'd go back and monitor, and if you swept or looked at the agent for, or not the agent, the plant for damage, which would mean there was presence of the agent, then you could see, okay, maybe I should add 5 more orders or something if you have a really big size. But they are small bugs. They are slow to move around, especially the leafy spurge beetles. They kind of just hop. So unless they latch on to another animal or something else that passes through, they're not going to be moving big distances. So that Pincher Creek photo of the 5-year difference is very impressive, but that's not always the case. Yeah, I don't know if that fully answered.
I think that is good. Awesome. Sweet. And thank you, Paige. I'll just move on to Emilia and I ask some questions around remote sensing and AI. There was a lot of questions about training, particularly how much is enough training, data imagery for AI model, and what the training is based off of. Is it color, shape, or any other physical characteristics?
Yeah, so I can answer that. So when it comes to the amount of training data, that's an excellent question. And of course, the answer is it depends. But definitely the the more the better, like on the order of like hundreds of examples. And uh, there are many different type of machine learning AI type of models. So some of those models are like pixel based. So in that case, you are looking at spectral qualities in the image. But when it comes for the models that I was talking about, we actually are looking more at the pattern. So we're looking at bigger sections of the image and looking at patterns of the leaves and the flowers. So it's more of a model similar to identifying like, is this a cat or is this a dog, or like where is the bike in this picture? Like that's the kind of model, I guess, except in this case, the question is, where is the um, can you find the giant hogweed in this image? So it isn't necessarily just spectral based. It's actually the pattern and the context in the image. And I think there was
Awesome.
more to your question, but
Um, yeah, I think you answered.
I think that
That
answered
was
it. Great.
Yeah, that was awesome. And let's see. Another question for you, Amelia, is can you and Ramboll help determine if a project or species is a good candidate for training an AI model?
Yes, we have ecologists that we work really closely with so we can kind of understand what is, what would be the best time of year to have the most differentiation between this invasive plant species and the native vegetation. So what is the time of year that we should be collecting imagery to have the most success in delineating that species in the imagery? So absolutely.
Awesome. Sweet. Okay, one last question. Uh, say an organization doesn't have a drone, and you mentioned satellite imagery. Is there any open source satellite imagery? Like, this might be a dumb question. Google satellite images, is that high enough resolution for like larger patches, such as Phragmites or something, or is it just too low resolution?
It could be for Phragmites. I would say if it's a widespread infestation, then you can see that in lower resolution imagery. Um, there's a lot of uh, there's a lot of drone companies, right? So you can contract with a drone company to collect drone imagery. But I would generally say that open source or public imagery is going to be n n probably not the resolution that you want to be able to see like a single plant. Uh, you'll want something higher than that. The USGS sometimes does collect drone imagery and make it public, but the chances that it's going to be available for your site is pretty low.
Awesome. Sweet. Thanks so much. Okay, I think we'll call it there. Thanks so much, Cheryl, Paige, and Amelia. Great presentations. And we appreciate everyone sticking around past the hour here.